All right, so graphing logs. Do you remember how to graph exponentials? Probably not, because it was before Christmas and everything you forgot. But hopefully as we go through this, you will remember some things, okay? Because graphing logs is exactly the same as graphing exponentials, but exactly opposite. That's like my motto for this. Exactly the same, but exactly opposite. So I'm going to take everything you know about graphing exponentials, and I'm going to reverse it. So I'm actually going to start with this guy right here. This is our parent function for log base 2, but I'm going to start with this guy. The very, very first thing you want to do is identify h and k. And I'm going to write it over here just because I'm going to leave this space for my rewriting. Okay? So, what do you think h is, if you had to guess? 2. Absolutely correct. It's in the parentheses with your x, and you always change the sign. What is our k value? Absolutely correct. Now's where everything starts going backwards. By the way, please note, I got h and k before I did anything to the equation. I have not touched the equation. I have not rewritten anything. Get h and k first. What was your asymptote before? Do you remember?
Y.
K. You would say y equals k, right? Our asymptote is not k. It's h, because everything is exactly opposite. I love how everyone's getting their highlighters now. Your asymptote is not k now, it is h. And your asymptote before, it was y equals k. Now it's x equals h. So my asymptote is x equals what? 2. What in the world does that look like? Well, if everything's opposite, it's not a horizontal line, it is a vertical line. Why is everything exactly opposite? Well, because the logarithm is actually what we call an inverse of an exponential. We talked a little bit about inverses last semester, about how it's that reflection over the line y equals x. This is the inverse of what we graphed before. Okay? All right, so if this gives me my asymptote, what does the other value give me? The middle value for my xy chart, right? But here's where the backwards part comes in. Instead of putting it in the middle of the x values, it goes in the middle of the y values. So I put my 3 right there. What did I do before? Once I have the middle, I fill in around there, right? So I'm going to do the 2 values below there and above there. So my k value has come right there. We okay so far? Now let's do our rewriting step. When we did the rewriting before, I said it's easiest when your log is on the left. Is it on the left here? No? So I'm going to take out the y equals and put equals y here, so that way it is on the left. You okay with that? Now, is my log alone? No. What do I need to do? Subtract 3. So, log base 2 of x minus 2 equals y minus 3. Now is my log alone? Yes. So I'm going to go to exponential form. What is my base? 2 to the what power? Y minus 3 equals, and then my last step to get x by itself, add 2. So what do I have? 2 to the y minus 3 plus 2 equals x. You okay with that? Now, here's the part that's funky. You're going to be plugging in y values, and what are you going to get out? X values. So it's a little bit backwards. So, I will say though, when you are using especially a calculator like this, you have to put that exponent in parentheses. So like on that homework key from last night, how the exponents were in parentheses, It's because when you're writing it as superscript here, it doesn't matter. But as soon as you go to your calculator, if your calculator doesn't have superscript where it bumps it up and shows that it's an exponent, you have to plug it in parentheses. So I'm going to start off by plugging in 1. So I have 2 to the parentheses, 1 minus 3. Now I'm going to close my parentheses because this plus 2 out here is no longer part of my exponent. And what do I get? 2.25. Now I want to plug in 2 instead of 1 because that's my next number here. So I'm not going to retype the whole thing. I'm just going to arrow back to the 1, highlight the 1, and change it to a 2. Hit enter. I have 2.5. Go back, change my 2 to a 3, and I have 3. Change my 3 to a 4, and I have 4. And change my 4 to a 5, and I get 6. So? Now, we have to be very careful as we graph because our brain is going to want to switch these points and graph them like we did before. Because remember, you would go like 1 over and then 3.25 up. It's opposite. No, you're not going to go up and over. You're still going to graph points the way you've always graphed points. That never changes. What changes is the decimal is now your x value instead of your y value. So I have to go over 2.25 and up 1. Does that make sense? And then I have to go over 2.5 and up 2. Are you following me? Do I need to zoom in? Now I'm going to go over to 3. Again, always starting from your origin. 1, 2, 3. 1, 2, 3. 4, 4. And then 6, 5. That's the funkiest part of this. But do you see how it's never going to cross my asymptote? Hooray! Because we don't want it to touch your asymptote, or to cross your asymptote, I should say. You got that? Now, what was my domain before when we did exponentials? All real numbers. Now it's not my domain that's all real numbers, it's the range that's all real numbers. And then my domain is either going to be x is greater than h or x is less than h. If my graph is to the right of the asymptote, it's going to be x is greater than wherever that asymptote is. It happens to be at 2, or my h value. Pretty easy? Okay, let's talk really quick about the transformation. The transformation, I'm going to go way back here to my h and k. If my h value was 2, that means I had a shift. What direction? Right 2. And if k was 3, I had a shift how? Up 3. So? Not too bad, right? You just got to remember to reverse everything you know. Okay? So, I'm gonna come back to the parent function. This is the basic one of log base 2. I'm going to do the more complicated ones, just so that we're all... I'm actually going to jump down to number 4 right now. What would you say is h in this case? Is there anything in parentheses with the x? So what would h be? 0. What would you say is k? -2. Notice I have not done any rearranging of anything. I'm just pulling out h and k. Which one is my asymptote? H. My asymptote is vertical through 0. And what would I write as the equation of my asymptote? X equals 0. If I wanted to talk about my transformation, what do I have? a shift. I don't have a shift left to right, do I? But I have a shift what? Down 2. Now I'm kind of curious, what's the parent function for this graph? What am I taking and shifting down to? Do you know? Well, if you cut off h and k, that's the parent function. So I'm taking the graph of y equals log base 1/3 of x, and that's what's being shifted. Up here, if you take off h and k, you are taking the graph of y equals log base 2 of x and shifting it. That's your starting point. Okay? All right, so let's see. What am I ready for? K. Where do I put k? Middle of the y values. So that goes right there. And then what do I do around that? -3, -4 on one side, and -1 and 0 on the other. And it doesn't matter if yours is -4 to 0 or 0 to -4, as long as those are the numbers you have. Now, do I start plugging it in? I cannot plug in until I rewrite in exponential form. So, again, my log is not on the left, so I'm going to go ahead and write the equals y over here just to keep myself from getting confused. And what would this be in exponential form? 1/3 what? 1/3 to the
y plus 2.
I can't do this yet, can I? Franken, you're slacking. I can't go there yet. I have to add 2 first. And I'm running out of whiteout, so fantastic. Okay, I have to add 2 first, because my log wasn't by itself. Log base 1/3 of x equals y plus 2. Now I can go to log form. Base is, I'm sorry, to exponential form. Base is 1/3. What's my exponent?
Y plus 2.
Equals, that's what I'm plugging stuff into. Okay, so do I need to put that exponent in parentheses? Yes. Do I need to put the base in parentheses? If your base is a fraction, I would on your calculator. It's not going to hurt anything. You can use your fraction button, probably. I don't see a need to if I'm using parentheses. So I have parentheses 1 divided by 3. And now I'm going to go to the, and I'm going to start with -4 plus 2. You okay with that? And I get 9. Now I'm going to go change that -4 to a what? -3. And I get 3. Now I'm going to change the -3 to a -2. And I get 1. Change the -2 to a -1. And I get 0.33. And change that -1 to a 0, and I get 0.11. Again, it doesn't really matter how you round off your decimals here, because when you're graphing it, you're not going to be able to tell a difference. All right, so again, make sure you're getting your x and your y's correct. I have over 9 and down 4. And then I have over 3, down 3. Over 1, down 2. Over 0.33, down 1. And over 0.11 and 0. Do you see what shape this is looking like? There we go. There's my curve. Okay, so let's talk domain and range. What is my domain? Which one's all real numbers? Domain or range? Range is all real numbers. What's my domain? X is greater than 0. I think almost all of our log graphs, it's always greater than. Okay? All right, so you all got your homework worksheet. I know I only got through 2 examples, but hopefully that was enough for you. Tuesday, I am going to do more examples. So if for some reason you're like dying this weekend and you can't figure it out, then at least do the rewriting step. Okay, so that you've got that. And finally, hang on just a minute. Here is my little cheat sheet. I have little hints for graphing. Identify h and k before you change to exponential form. Remember, h is your asymptote. K is the middle y value on your xy chart. And rewrite in exponential form before you start plugging in values. That's kind of a summary of what I just went over with. Okay? Happy studying.